Hi everyone. In today's lecture, we are going to discuss about the primitive data types. Fine. So, primitive data types are the basic data types which are used to store single value. So, we have 8 types of primitive data types, basically divided into three different categories. The first one is numeric data type. The second one is char data type. The third one is Boolean data type. Fine. So, this numeric data type is used to represent numbers. Okay, char data types are used to represent character. Boolean data types are used to represent logical values. So this numeric data type is divided into two parts. The first part is what? Integral data type, and the second one is floating point data types. So these integral data types are used to represent whole numbers, and the floating point data types are used to represent which number? Real numbers. Real numbers. Fine. So in integral data type, we have four different data types. That is what? Byte, short, int, and long. And in the case of floating point data types, we have two data types. That is what? Float and double. So I hope this much is clear to you. Now let's cover the integral category first. This integral category. Fine. So, the purpose of integer category data types is to allocate sufficient amount of memory space for integer data in the main memory of the computer. That is what? In RAM, right? This is the purpose of this integer category data type. Fine. Now, except Boolean and char data types, all remaining data types are considered as signed data types because we can represent both positive and negative numbers using numeric data types. Fine. This is very simple point. Is it clear? Do you think we have negative false or negative true value? Do you think we have minus A or plus A something? No, na? This positive and negative concept is applicable for what? Numbers, right? That is the reason I am saying this. Except Boolean and char data types, all remaining data types are considered as signed data types because we can represent both positive and negative numbers using numeric data types. Fine, this much is clear to you. Now let's move ahead. So we will cover first what? Byte. Fine, let's cover the byte first. So this byte, this byte data type has the size of 1 byte, means 8 bit. This data type has what? What is the size of this? 8 bits, means 1 byte. Is it clear? Now next, it has a minimum value of minus 128 and maximum value is plus 127. So what is the range? Range is 1 byte. 1 byte means 8 bits. 8 bits. Okay. So the range is what? Minus 2 to the power 7 to 2 to the power 7 minus 1. It means minus 128 to 127. Okay. This much is clear to you. Any doubt in this? No, right? Fine. So now let's see how to represent 8 bits. Like this we can represent. Like I'm considering the maximum case. In the max value case, everything is 1 1 1 1 1 1 and 1. And this last bit, it is what? Most significant bit. This bit is called as what? Sign bit. And in the case of sign bit, 0 represents what? Positive number, and 1 represent what? Negative number. I hope this much is clear. Fine. So now let's see. So here MSB acts as a sign bit, means most significant bit acts as a sign bit. So the positive number will be represented directly in the memory, but in the case of negative number, it will be represented in 2's complement form in the memory. Please make it clear these things. Now let's see some examples. So example first, byte b is equal to 10. What was the range of this byte? Have you seen what was the range? Minus 128 to plus 127, right? So this 10 lies between this minus 20, 128 to 127, right? So this is what perfectly valid case. This is what valid. It will work, no issue. Fine. Now let's see the next example. So byte b is equal to what? 10.5. Before concluding anything, let's do a practical and check whether it is valid or invalid. Byte b is equal to 10.5. So for that, let's do it by the help of notepad. Okay, so I have this program already present in which I have declared one class, and the class name is what? Data type demo. You can also take this example. So I have the main method public static void main string args, and what is my point here? Byte b is equal to 10.5. 10.5. Now save this with the name of class. Like, what is the class name? Data type demo dot java. Fine. Now save it. I'm saving it at this document location, right? Save it. Now go to that location where you have saved your file. What was the location? Document location. Here is my file, data type demo.java. Open the cmd here, cmd command prompt. Now do compilation, means java c data type. What was the name of file? Data type demo. Yeah, data type demo.java. Hit enter. See, what is this? What is the error you are getting? Incompatible type, possible lossy conversion from double to byte. Means what you are trying to do? You are trying to assign the double value to the byte. Is it possible? Just now we have covered there are two categories. First one is integral and the second one is floating point. And this double comes under floating point category, not under the what? Integral category. That is the reason it is saying it is of what? Incompatible types. So what is the error? You will get here what? Compile time error. You can note down this error if you are preparing a notes. Okay, this is the error you will get in this case, because I can't note down because I'm running this PPT, but you can do. Fine. So here you will get what? Compile time error. Fine. And this is what? Invalid. Now next, what I'm trying to do? Byte b is equal to true. Again same thing. This true is what? Boolean. This true is what? Boolean value, right? Boolean value. How can you assign a Boolean value to the byte data type variable? Is it possible? Not possible, because Boolean is a completely different thing. It is not a number. It is not an integer, right? And this byte is holding what values? Integer values. We are seeing this in which category? Integer category, right? So it is also invalid, and you will get the compile time error in this case also. You will get what? Compile time error. If you want to see, let's see. Where is that program? It is the program, right? So instead of 10.5, now I am typing here true. Save this and go to the CMD once again and run the Java C type demo.java. Compile this program once again. See, I am compiling. What is the error? Same error. Incompatible type. It means Boolean cannot be converted to byte. Right? You're trying to assign the Boolean value to the byte type. It is not possible. It is what? It will give you the error, because here in this case, Boolean is completely different thing, right? It is not integer data. Fine. Now let's see next. So here also you will get what? Compile time. Best choice, byte type is the best choice if you are handling data in the form of streams. either from file or from the network. Okay, then you should go for which data type? Byte data type. Or is it clear? Okay, now next data type, which is what? Short type. So short type, so this data type is basically, very rare used data type. You will not going to use this data type at all, trust me. Okay, you are not going to use. So what is short data type? How can you define? Integer data type whose size is 2 bytes is called as short data type. Fine. So size is how many bytes? 2 bytes. 2 bytes means 16 bits. 1 byte means 8 bits, right? 8 bits. So 2 byte means 8 into 2, that is 16 bits. And what is the minimum and maximum? So it has a minimum value of minus 32,768 and the maximum value of plus 32,767. Now it can hold the values between these two values, and it can also hold this value as well as this value also. Fine. This type of data type, which one? Short data type. So what is the range? Range, simple formula, 16 bytes means minus 2 to the power 15 to 2 to the power 15 minus 1. It is the range. It can allow the value from this to this. So short data type is the best choice while working with 16-bit microprocessors like 8086 microprocessors. You might have, anyone from the electronics background, they might have heard about this subject, 8086 microprocessor. We have learned this subject, right? So these processors are outdated now. These processors are outdated. Because of this reason, short is rarely used now. Short is what? Rarely used. Fine. This thing is clear. So you can use short to save memory in large arrays in situation where the memory saving actually matters. In that case, you can use this short. Fine. Let's see some examples. For example, short s is equal to 130. See, 130 lies between this value, right? So this is what? Perfectly valid case. Now, next example. Short s is equal to 32768. But the maximum value allowed is what? 32767. So do you think it will work? It will work? Do you think it will work? Let's see. Go to this and do what? Short s is equal to 32768, right? It was 32768, right? Now save it. Go to the CMD. Try to compile this. First, let me clear this. Clear. Oh, CLS. Okay. Now let me compile this first. So I'm compiling this program. See, what is this? You are getting an error like incompatible types, possible lossy conversion from int to short. Right? So you will get a compile time error. One point. By default, every data type is of what type? Int type, right? By default, every literal is of what type? Int type. So here this value exceeds, that is the reason it is considering it as what? Int. So it is what? Invalid. Compile time error. Because the maximum allowed value is what? 32767 only. Now let's see the next one. Sort s is equal to Naveen. This Naveen is what type? String type. How can you assign a string type value to a short type of variable? It is what? Integer variable, right? Integer variable. How can you assign a string value to integer variable? Is it possible? No, you will get compile time error also in this case. If you want to see, let's see. Here I'm passing what? Naveen. Naveen. I'm saving it and I'm going to this CMD. I'm trying to compile once again. See, incompatible types. A string cannot be converted to short. Clear? Let's move ahead. I think this much is pretty much clear to you. Now we have to see the int type. Fine. So int. So in the int case, what is int? You know, the most commonly used data type in Java is int. Integer data type whose variable, whose size is 4 bytes, means 32 bits. And what is the range? Range is this: -2147483648 to 2147483647. It means the range lies between -2 to the power 31 to 2 to the power 31 minus 1. This is the range. Now let's see the example. Example: int I is equal to 130. Int I is equal to what? 130. So this 130 lies between this value, right? That is why this is perfectly valid. It is valid. Now let's see this. Int I is equal to 10.5. 10.5 is of what type of data? Don't you think it is double type data? Double type data. Okay. So if it is a double type data, how can you assign the double type data to this int type of variable? Is it possible? Not possible. If you want to see, let's see the example. Int I is equal to 10.10.5. Save this, go to the CMD, try to compile this. See, what is the error? Incompatible type, possible lossy conversion from double to int. So let's go to the PPT once again. So it is what? It is what? Invalid, means it will give you the compile time error. What was the compile time error? That you know. We have just shown that to you. That is incompatible type. Right? Possible loss of, what was the error? Read this once again. Possible lossy conversion. Fine. Now let's see the next example. So int I is equal to false. Again, what I'm trying to do here? This is what? Boolean type of value. I'm trying to assign to int type of variable. Is it acceptable? No. You will get the compile time error saying that incompatible types. Incompatible types. It is always good to check once, okay? It is always good to practice this thing. What if you will do like this? Here I am passing the false. Saving this, going to the command prompt, running this command javac data type demo.java, hitting the enter. See, Boolean cannot be converted to the int, incompatible type, right? So I hope this much is clear to you. Now, the bonus point is what? In Java SE8 and later, you can use the int data type to represent an unsigned 32 bits integer also, which has a minimum value of 0 and maximum value of 2 to the power 32 minus 1. We will have to use the integer class to use int data type as unsigned integer. By default, this all whatever we are learning is what? Signed data types, right? Because you can represent the negative values also and the positive values also. But if you want to represent only the unsigned values, it means in this case, see, from 0 to max value is 2 to the power 32 minus 1. Then you have the way from Java 8 and later you have the way you can use this integer class. Fine. Now let's see the next is what? Long data type. So long data type, see, whenever int is not enough to hold big values, then we should go for long data type. Make this thing clear, okay? Example, example, to hold a number of characters present in big file. Suppose you have very big file and you want to count the number of characters and you want to store in some variable. So to hold a number of characters present in big file, int may not be enough. Hence the return type of this length method is long. It is already a defined method. It is already a predefined method, and the return type of this method is what? Long. I'm just explaining why they have given this length method return type as long, because to hold the number of characters present in the big file, int may not be enough. Hence the return type of length method is what? Long. For example, this, see, f is a file, so f dot length, it will return you long value. Fine. What is the size of this long data type? 8 bytes. 8 bytes means how many bits? Tell me. 8 into 8, right? 64 bits. 64 bits. Is it clear to you? Fine. What is the range? If it is 64 bits, then what is the range? Minus 2 to the power 63 to 2 to the power 63 minus 1. Simple. Now see, again the same concept. In Java SE8 and later, you can use the long data type to represent an unsigned 64-bit integers also, which has a minimum value of 0 and the maximum value of 2 to the power 64 minus 1. The long class also contains method like compare unsigned, divide unsigned, etc. to support arithmetic operations for unsigned long. Is it clear? This all features are available from the Java SE8 and later versions. I hope this much is clear to you. Now we have covered integer category, right? The next thing that we have to cover is what? Floating point category. So as you know, byte, short, int and long can be used to represent the whole numbers. If we want to represent real numbers, then we should go for floating point data type. What I am assuming is you better know what is whole number and what is real number in mathematics, right? That is why I'm not explaining this thing. So basically byte, short, int and long can be used to represent the whole numbers. If we want to represent real numbers, then we should go for floating point data types. What is the example of this real numbers data? Like 10.7, minus 78.7, 23.9. This all are what? A floating point values, right? This all are floating point values, and if you want to store this kind of floating point values, we have to use this floating point category data types. Floating or floating point category data type, right? This is what the need of floating point category. So in this we will cover first what is the float. So it is what is the float? Anyone? Okay, fine. So float is what? It is a real data type having precisions. Having what? Precisions. For example, size of this data type is what? 4 bytes. And the range of this data type is what? Minus 3.4 E38 to plus 3.4 E38. It is an exponential representation. If you are really good in math, you might be knowing these things. If not, you can Google it, and if you can search this. Okay, it is a very simple thing. No need to worry about that. So float point values must be suffixed with the capital F or small f. Remember this point. And float can allow only 7 bit of precision, and float follows what? Single precision. For single precisions, 32 bits are used to represent the floating point numbers. That is why it is what? Single precision. Now the next thing is what? Double. We have double also in the floating point category. So double is also a real data type having precision up to 15 bits. Is it clear? having precisions up to 15 bits. Hold on, go back. So okay, float can only 7 bits of precision. Yeah, it is right. So double is also a real type data having precisions up to 15 bits. That is the reason double gives more accurate data. More accurate data. Fine. And you know the size of data type is 8 bytes, sorry, 8 bytes in this case. And what is the range? The range is minus 1.7 E308 to 1.7 E308. And double follows what? Double precision. For example, what does it means for double precision? 64 bits are used to represent the floating point number. That is why accuracy is more here in the double. Accuracy is more. Fine. Now let's see some examples. I have float f1 is equal to 100. I have this. What? Float f1 is equal to 100. So what do you think? Is it valid or invalid? Is it valid or invalid? Go and check. Now see this float f is equal to 100. Fine. Now go and do the compilation. Compiled fine. Run it. Java data type demo. Running also fine. It means it is 100% what? Valid. It is what? 100% valid. Hold on. It is what? 100% valid case. Valid. Fine. Now the next. The next thing is what? What I'm trying to do. Float f2 is equal to 100.0. 100.0. So in this case, this data was of int type, right? Because every integer numbers by default having the int data type, right? And every floating point number has a default data type is what? Double. Remember this point, double. For the floating point numbers, double, and for the integer number, int is the default data type. This thing you should remember. So see this thing. So what I'm trying to do here, float f2 is equal to 100.0. Now let's go and check this. Let's go and check this 100.0. Go to the CMD, try to run, try to compile first. See, what is this? Incompatible types, possible lossy conversion from double to float. Now you might be thinking how it becomes double. See, my friend, default data type is double for the floating point numbers. If you want to make this as float, then what you have to do, you have to suffix this value with capital F or small f. Otherwise it will treat this value as double type, and you can't assign the double type into the float type. Double type is of 8 bytes and the float is of 4 bytes, right? You can't assign this. That is the reason you are getting this error here, possible lossy conversion from double to float. So this will give you what? Compile time error. Fine. Now the next. This time I have appended this f here, so it will work perfectly. If you want to see. Now write f here, save it, go to the CMD, check, compiles perfectly fine. No, if you want to run it. Hold on. You can run it and you can check. Run this. See, perfectly fine. There is no issue at all. So this is perfectly fine. The next example. Now double d1 is equal to 100. So this is also, perfectly fine. It will work. You can assign the integer type of value into the double. No worries at all. Now the next. Double dt is equal to 100f. Yeah, you can assign the float point of value also to double. This is what? Float type value, right? Because f is present here. And float is what? 4 bytes only. And double is what? 8 bytes only. Do you think any loss will be there? If I will assign 4 bytes of data in 8 bytes, no loss, right? So it is 100% valid. Now the next, double D3 is equal to 100D. D D specify what? It is of what type? Double type. Small d or capital D. You can use small d or capital D. So this is also perfectly valid. I can assign the double type of value in double type of variable, right? So this is what about the double. So when we were not specifying anything and when we were passing this floating point value, and then at that case it was considering it as what? Double, because the default data type for the floating point numbers are what double, and for the integer numbers it is int. Remember this point. Now let's see next, Boolean data type. For the Boolean data type, size concept is not applicable, you can see. Simple. Or in another word, it is virtual machine dependent. It means it is JVM dependent, right? Now range concept is also not applicable, but the allowed values is what? True or false. In the case of Boolean, what is the allowed value? True and false. I hope this much is clear to you. Fine. Now let's see some example. Example, Boolean b is equal to true. See, this true. It is 100% valid because allowed values are what? True or false. Now I have changed this true. In the first case, everything was in lowercase, but here the t is in uppercase, and then rest of the things are what? In lowercase, right? Now, do you think it is valid? Do you think it is valid? No, it is not valid. What we have learned in the reserve words, that every reserve word should be in lowercase. This true is in lowercase in the last lecture. False also should be in lowercase. But if you are writing like this, then what does it means? Let's see that thing first. Here, what I'm doing, I have this Boolean b is equal to true. True. Save this. Go to the CMD. Compile this program. See, what is the error? Error is cannot find symbol Boolean b is equal to true. Symbol variable true. It is treating this true as a variable and it is looking for this variable, and it is not able to, your compiler is not able to find that variable. That is the reason it is saying cannot find symbol. Which symbol? This true symbol. In which location? Class data type location. Data type demo location. Fine. I think this is clear. So in this case, it will treat this true as what? A variable. So you will get compile time error. Fine. It is invalid. Invalid case. You will get compile time error in this case. Now let's see the next example. Boolean b is equal to true. You are passing the true in the double quotes. Anything you are passing in the double quotes is treated as a string. So is it possible to assign the string type of data in the Boolean type of variable? Not possible. Again, you will get what? Compile time error. And what is the compile time error? Let's see. Enclose this in the double quotes. Save this. And go back and compile this. And see the magic. What is this? Incompatible types. The string cannot be converted to Boolean. Right? It is not possible. So you will get what? Compile time error here. Now the last one. Boolean b is equal to 0. Fine. This 0 is of what type? Int type. Again, you are trying to assign a integer data to the Boolean. Is it going to work out? No, you will get compile time error. Right? It is not a C programming language where 0 means false and 1 means true. These concepts are not applicable in Java. Remember this point. In Java, this true means true, okay? And this false means false. There is no story like, okay, 0 means true, 0 means false, and 1 means true. No such story applicable in the Java. Remember this point always. So default value is what? False for the Boolean data type. Fine with this? Now next point, char data type. So char is what? Character data type. What is the size? 2 bytes. And what is the range? Range is from 0 to 65,535. You know, you should ask one thing, that in the languages like C and C++, the char size is 1 byte. What is the need of 2 byte in Java? You should ask this question. So, my friend, languages like C and C++ are ASCII based. Which based? ASCII based. Fine. ASCII based, and the number of allowed different ASCII code characters are less than or equal to 256. Fine, less than or equal to 256. So to represent 256 characters, 8 bits are enough. 8 bits are what? Enough. That is the reason. That is the reason in the old languages like C and C++, the size of the char is what? Size of the char is 1 byte. 1 byte. But Java is Unicode based, and the number of different Unicode characters are greater than 256 and less than or equal to 65,536. Fine. So the number of different Unicode characters are greater than 256 and less than or equal to 65,536. So to represent these many characters, 8 bits are not enough. 8 bits are not enough. That is the reason we should go for 16 bits. 16 bits. Hence, the size of the char in Java is 2 bytes. This is the reason the size of the char in Java is what? 2 bytes. 2 bytes. Now I hope this thing is clear. This is not ASCII based. In Java, it is what? Unicode based. So the size is 2 bytes and the range is this. Now let's see the next. This is what the same explanation. Let me erase this first. Okay. Pointers, erase all. Okay, fine. This point explains the same things that I have just described. Now let's see the examples. Like char ch1 is equal to 97. So what is this 97? Do you think it will work? It will perfectly work. You know, you are passing 97, so what it will do, it will it will consider is it as what? Unicode. Fine. And it will find out the equivalent character. Equivalent character. So it is perfectly fine. For example, let me show you. So what is this? Char ch1 is equal to 97. System dot out dot println ch1. I have saved, I have compiled this, and I want to run this. So Java data type demo. Hit enter. See, the value is small a, right? So in the Unicode also 97 means small a. So equivalent character is what? Small a. So you will get small a in the output. Means equivalent Unicode for this small a is what? 97. I hope this thing is clear. Now next, char ch2 is equal to 65,536. But the max allowed value is what? 65,535. So it will not work. You will get the compile time here. Compile time error. It will not work. It will say something like possible loss of precision or lossy. Right? You want to see? Let's see. Everything you should practice. Everything, each and everything you should practice. I have saved this. I'm going to this, trying to compile this. Now see, possible lossy conversion from int to char. Fine. So this is what? Invalid. Now the next. I'm assigning this null to this char type of variable C. What we have learned in the last lecture around this null is a default value of object reference, right? And we can't apply for primitives. So here also you will get compile time error like incompatible type. Incompatible types. You can check this, okay? You can check this by on. So null is what? Null is what? Default value of object reference, and we cannot apply for primitives. If we are trying to use for primitive, then we will get compile time error. This much is clear. Now the last. See this thing, you have to go through this for the revision purpose. Fine. Here I have shown you the default values. This is the default values in Unicode format. This is what the Unicode in Unicode format. And you know what is this? What is this? It is nothing but 0. Equivalent 0. Fine. So thanks for your valuable time. Please subscribe our YouTube channel for further updates.